Welcome to section 7.2, instantiating objects. In this lesson, we're going to explore what really happens under the hood when you create new objects in Java. We'll talk about memory, references, and why two identical looking objects can still be totally different. Here's what you'll learn in this lesson. You'll understand what happens in memory when you create objects. You'll get how object references work and how they're different from primitive values. You finally grasp the difference between stack and heap memory, and you will see why strings are a little bit special. Let's set the scene. It's later that night and everything is awesome. Your software is a hit, banks are booming, and kids are happy. Life is good until the criminals show up. Well, we've got thieves, and what do they need? A prison. Time to level up. We're writing code for an entirely new system. You're now in charge of programming software for prison management. Let's start by modeling a prisoner. Just like before, we will list our properties and behaviors. Here's how we describe a prisoner. Its properties are name, height, year sentenced. Behaviors, maybe just one, something like thinking about what they have done. Okay, let's go with that. In exercise 1, part 1, create a new project, write two classes, prison test with a main method, and prisoner with name, height, and sentence fields. Then instantiate two prisoners, Twitch, his height is 5'8" or 1.73 meters, and sentence 3 years. Baba, 6'10" or 2.08 meters, 4-year sentence. Feel free to use meters instead of feet or inches to simplify the math. In exercise 1, part 2, can Twitch impersonate Baba? First, check if Baba equals to Twitch. It should be false. Then make Twitch's properties identical to Baba's. Check again, still false, and we'll explain why in a second. Your prisoner class may look something like this. Simple but solid blueprint. Back to our test. Even after setting Twitch's fields to match Baba's, Baba equals Twitch is still false. Why? Because Java is checking if they live in the same memory address, not whether they look the same. That's the key. Here's the visual. Think of each prisoner having a separate cell. Even if two prisoners look identical, they are in different locations, so they are still separate objects. So when you write prisoner Baba equals new prisoner, prisoner Twitch equals new prisoner, you're actually assigning each one to its own spot in memory, its own cell. And this happens thanks to the new keyword. New tells Java, find me a free space in memory and create a new object there. You don't need to know the exact memory address. Java handles that for you. But if you print the object directly, like system.out.println Baba, Java shows you something like prisoner at some hexadecimal number. That is the hash code of the object. Same class, different object, different address. So even if two objects have the same properties, as long as they were created using new, they are different. Different memory, different identity. Objects are accessed by using reference variables. A good analogy is using a remote control, the reference, to operate a camera, the object. The buttons on the remote control can be used to trigger a particular camera behavior. For example, you can use the remote to call the camera's stop, play, or record functions. Let's examine the analogy of using a remote control to operate an electronic device. To operate an electronic device with a remote, you need to do what? 1. Pick up the remote and possibly turn it on. Then press a button on the remote to do something on the camera. Similarly, to do something with the Java object, you need to get its remote, calling the reference, and press its buttons, calling the methods. There are two camera objects in this example. Each camera has its own unique remote. Remote 2 won't work on Remote 1's camera, and remote 1 won't work on remote 2's camera. This reflects how in Java two different objects can be instantiated with their own unique references. These references can be used to call methods on their respective objects. The diagram shows another important aspect of how references work. In this example, a camera object is created with the reference remote 1. This reference is then assigned to another camera reference, remote 2. Both remote 1 and remote 2 references are associated with the same camera object. Calling methods using either reference affect the same camera object. Calling remote1.play is no different than calling remote2.play. Working with different types of objects, for example, a camera and a television, requires a remote specific to that object type. In Java, you need a reference variable of the correct type for the object you are referencing. In this slide, we see the variable's type is set in the declaration process and the object type is set in the object instantiation process. Because Twitch variable is of prisoner type, it can't impersonate a TV object to full security. In exercise 2 back in your present test class, instantiate Baba and Twitch again. Then run this line, Baba assigned Twitch. Now try printing their fields and checking Baba equals Twitch. You'll see that they point to the same object. Desktop memory. Java uses two types, stack memory. It holds local variables and references. Heap memory. It holds the actual objects. References in the stack point to data in the heap. This diagram shows how reference variables point to a particular object in memory. There are two prisoner object references pointing to two prisoner objects. Stack memory holds local variables, either primitives or reference variables, and the heap holds objects. So in this diagram, Baba and Twitch are variables in stack memory. Each of them point to a prisoner object in heap memory. After Baba assigned to Twitch, both Baba and Twitch reference variables now point to the same object. You want to prove? Try this. Printing baba.name results in Twitch being printed because both baba.name and twitch.name reference the same field in the same object. But primitive types like int x equals 1 are a different story. They don't reference objects. They hold values directly. Assigning one to another just copies the value. Here is something interesting. What happened to the original Baba? If no references point to that object anymore, Java deletes it. This is called garbage collection. Java automatically reclaims memory that's no longer needed. Language like C++ make you clear memory manually. Now let's talk strings, which are special. When you create a string like this, string s equals test, Java reuses that object if the same string already exists. But if you use new, you force it to create a brand new one. In exercise 3, try both approaches in your project. Set names using new string Baba, then try with just Baba. Use double equal sign to compare both times. You'll see different behaviors. With new, you get two objects. String s1 equals new string test. String s2 equals new string test. Different memory addresses. S1 double equal sign, S2 is false. Without new, Java optimizes. String s1 equals test. String s2 equals test. Same object in memory. So s1 equals s2 is true. And if you do this, string s1 equals test, string s2 equals test, s1 equals different. Now you are pointing s1 to a new object. S2 still points to test. Strings are immutable and references stay independent. To wrap it up, here's what you learned. The new keyword creates objects in heap memory. References live in stack memory and point to those objects. Two objects with the same data could be different and equal in memory. Double equal sign checks references, not content. Strings are optimized for memory and behave a little different.